So one of the first things I use is penetrant stabilizer, and this will glue the tiny things. And we only want to put this in places where I want the bone or the tooth to be stuck together. It'll go in and it'll fill these little cracks in the jaw here. Because we don't want this coming apart as we transport it back to the lab. And this has a very, very thin cyanoacrylate, so it has capillary action. It's got what they call rollers and kickers. Capillary action, it'll flow all the way up the crack, and then once it stops flowing, then it kicks, which means it starts to set. So that way it absorbs really deep inside the bone structure. And so I just want to get all the little cracks with this thing. A little capillary tube on top. You just need little drops of this. Here, well, the big cracks I don't want to glue, because when you get back in the lab, I might be able to move that little piece of the tooth and put it back together.
So once it's glued, it's stuck together. Yeah. It's not going to come unstuck.
Well, you can unstick it, but
you don't want to.
You have to put a solvent on it.
Okay.
This is vinyl acetate.
Okay.
And basically, they're archival plastic beads dissolved in a solvent.
Okay.
And when the solvent evaporates, it leaves the archival plastic inside the bone.
Left behind. Okay.
All these little boxes represent tooth kits. And what that I mean is that fragments of a tooth that were closely associated and broken up are tried to put in separate boxes. So when they're back in the lab, they can be more easily assembled. But no guarantee all the fragments go to the same tooth. But we are finding probably at least 4 or 5 different teeth now, based on tooth tips, tooth crowns, and things like that. So what we've done now, we've picked up all the little tiny fragments and placed them in small quadrants and labeled each bag for each quadrant, so it'll make assembly back in the lab easier. We've also separated the tooth fragments into these little Tupperware boxes that are generally the same little small area about this big, in hopes of being able to reconstruct those teeth better in the lab. We've left a massive bone fragment here that we really have just pretty much hardened in place, and we've left the original maxilla or upper jawbone to the Tyrannosaur right here in place as well. It's all broken and busted up along the back, and the tooth is still broken, so we'll work on this after we pick up these bags. We'll sweep this area clean, and then we'll dig down a few centimeters to see if we can find any other bone. Then it'll be safe to start digging on the specimen here without having to worry about covering up pieces to it that we may have missed. So what we want is a nice clean surface. So if we find any other bone, we're going to find it using the brush at this point. We've picked up all the small pieces. We've probed around with little scalpels. And so now I'm just brushing the surface clean to see if there's anything embedded in the harder matrix. And the constant brushing reveals more bone. The little tiny pieces of tooth fragment here that we're collecting. So right now we're trying to determine whether this bone is in situ, whether it's in the position in which it was buried, or whether it had fallen off the hill and then gotten covered up by weathering. So the object is to just follow the bone back into the formation. We do this not only to find out if it's in situ, but also we're getting ready to put a plaster field jacket on it. And we need the entire bone exposed in order to do this.